Okay, now we're going to be talking about the dwarf planet Pluto. So Pluto was demoted from the status of being a regular planet like Earth to just being a dwarf planet. So first you got to know, what do we mean by a dwarf planet? And so Pluto is so small, it doesn't generate enough gravity to be able to clear out its orbit of debris. So as the planet Pluto orbits around the sun, there is constantly debris that it's bumping into. And the other planets in our solar system have enough gravity to be able to sweep out all of that material as they go around. So that's the definition of a dwarf planet. Something that's interesting about Pluto is its orbit. Occasionally it's inside the orbit of Neptune. So it has a very elliptical orbit, has a large eccentricity. So that if this is the sun right here and then this is the orbit of Neptune, then most of the time the orbit of Pluto is outside of the orbit of Neptune, but occasionally it goes inside and then goes back outside again. So some scientists have felt that this is some kind of a clue that shows that Pluto is an escape moon of Neptune. There's other astronomers that don't believe that that's true. But occasionally its orbit is inside. Its orbit, it takes like 200 years for Pluto to orbit the sun. So that means the last time that Pluto is where it is today was 200 years ago. Now, we didn't really know that much about Pluto until just a few years ago when a space probe actually got there. And so all of this information that I'm giving you now is a result of that space probe. So the internal structure of Pluto. So it does have a crust, but as opposed to the crust of the Earth, which is composed of rocks, granite and basalt, the thin crust of Pluto is going to be composed of water with trace amounts of ammonia and carbon monoxide and nitrogen, and it's going to be in the form of ice. Then underneath it, it has a mantle, so just like the Earth, but the mantle of the Earth was composed of very dense rocks, as opposed to the mantle on Pluto, which is composed of water. And the upper part of the mantle is solid water, ice, and then underneath it there is liquid water. And then it does have a core, and the core is composed of rock. We don't exactly know what kinds of rock it is, but we can assume that it's very similar to the kinds of rock found on Earth's moon. Then you have surface features. So it has a very young surface. The surface of Pluto is only about 10 million years old. Now, that was a shock to scientists, because if you think about what's the surface of the moon like, it's heavily cratered. But then when they went to Pluto and looked at it, it wasn't so cratered. And that's an indicator that something must be covering up the craters on Pluto. Another thing that they found was that it has ice volcanoes, and that these volcanoes produce ice nitrogen, and it also has nitrogen glaciers, and it also has liquid nitrogen on the surface that kind of simulates lava, so that this liquid nitrogen is capable of flowing on the surface of Pluto, and then that's what helps to cover up all of those craters and gives it that young surface. Now the heat source. So this is also going to be very similar to Uranus, Saturn, and Jupiter and Neptune, in that it's a phase change. So what we think is happening there, as water is changing from a liquid to a solid, it gives off heat. And so that is the heat source for the planet Pluto, which drives, I'll put it in quotation marks, plate tectonics. So in the same way that the Earth has plate tectonics, which would be rocky lithosphere that's moving around, bumping into each other, making mountain ranges, making volcanoes. Well, a similar kind of process goes on Pluto, but it would all be based on ice. So this heat that is welling up from the inside of the planet causes ice to shift around on the surface of Pluto, and so you can say it's kind of like a plate tectonics type deal. The atmosphere is composed of nitrogen, methane, and carbon monoxide. The pressure is 1/20,000,000th of the pressure that we're experiencing here on Earth. So for all intents and purposes, it doesn't really have much of an atmosphere. It's kind of like the moon. And then the temperature varies between -240 degrees Celsius to -226 degrees Celsius. So even when you're in the sunlight, it's not that much hotter on Pluto because the sun is so very far away. Another interesting thing is it has a super summer, and that means that occasionally, whenever the orbit is just right for Pluto, it experiences a little bit more energy from the sun, and it has the super summer when it might get up to the blazing temperature of -227 degrees Celsius. I don't know. But it does get a little bit warmer on the surface during one of these super summer things, which happens every 1,000,000 years or so. There are other objects further out than Pluto. And so you'd hate to have to memorize all of these other objects out there. So it's just as well that Pluto was dropped as being one of the major planets in our solar system. So you got Pluto, and then the next one out is called Orcus, and then I'm not going to pronounce those other names. I believe that all of these names are based on North American Indian names. And so you see that Eris down there is actually larger than Pluto. And so all of these objects are further out than what Pluto is. And we think that they're basically composed of the same kind of things than what Pluto is, basically have the same kind of atmosphere as what Pluto is. All right, let's take a break, and when we come back, we'll now start to talk about the moons of some of the planets in our solar system.